Check out this speaker. If we plug it in, it makes sound. The way this speaker creates sound is by moving the front of the speaker, which is called the diaphragm, back and forth rapidly. Scientists often use the word oscillation to refer to the back and forth motion of an object. This speaker's oscillating too fast for the human eye to see, but if I put a piece of paper on the speaker, we see that because the diaphragm is oscillating, it's bumping into this piece of paper and causing it to dance. The oscillation of the diaphragm will also cause the air in front of the diaphragm to move back and forth. But here's the interesting thing. The air in front of the diaphragm doesn't actually travel away from the speaker. The air molecules in front of the speaker just oscillate back and forth. So how can you hear the sound from a speaker if the air next to the speaker doesn't actually make it to your ear? Well, the reason is that the oscillating air in front of the speaker causes the air in front of it to also oscillate. This causes the air in front of that air to start oscillating, which causes the air in front of it to start to oscillate, until finally the air that's actually next to your ear and your eardrum start to oscillate back and forth. This oscillating air that's next to your ear is moving, so it has kinetic energy. So it can transfer energy into your eardrum, which you can perceive as sound. So this speaker was able to transport energy through the air without actually having to transport the air itself. This is an important enough fact for me to state again. Energy is traveling across the room here, but air itself is not traveling across the room. Only the disturbance within the air is traveling across the room. If air were being transported across the room, it'd be better characterized not as sound, but as wind. So this is why we call sound a sound wave, because it shares the defining feature of waves, which is being able to transport energy through a medium without having to transport the medium itself. Medium is a fancy word for the material or substance through which a wave is traveling. Air is typically the medium for situations involving sound waves, but sound waves can travel through all kinds of different materials, like water, metal, or even human flesh and bone. And the fact that sound can travel through human flesh and bone explains something you might have always wondered about, which is, why do our voices sound so different on audio and video recordings? The reason for this is that when we're speaking to someone, we actually hear two contributions from our voice. We hear the sound wave traveling out of our mouth, through the air, and into our ear. But we also hear the vibration of the sound wave traveling through our flesh and bone, through our skull, and into our eardrum. But on an audio or video recording, the only part that's recorded is the sound that travels through the air. So when you hear your voice played back on an audio recording, you only hear what other people hear when they listen to you. So the bad news is that, yes, what you hear on audio recordings is actually what you sound like to other people. But the good news is that most of your friends probably don't think it sounds weird, since that's the only voice they've ever heard you use. Unless you do actually have a weird voice, in which case I'll risk sounding pretentious by reminding you that you shouldn't waste a lot of time worrying about what other people think of you anyways.